Hello everyone, welcome to the video explanation for Brian Passwater's topic 2.8 notes, example 7. Example 7 is an extension on example 6. It shows some more complicated functions, and it allows us to again check to make sure that the functions are inverses. Now sometimes when we do that, we have to use a restricted domain. And the reason that we have to use a restricted domain is so that both the function and its inverse are in fact functions. So when we look at this function k of x, or h of x is a parabola. Well, parabolas open up or open down, and those curves do not pass that horizontal line test. There are multiple inputs with the same output, which means that technically the inverse of h of x would not be a function. However, by restricting the domain to x is greater than or equal to 10, we're only looking at 1/2 of h of x, which means that we don't have that problem. So when you see a problem like this and it says show that h of x and k of x below are inverses, where x is greater than or equal to 10, do not get thrown off by this. Okay, this doesn't affect the approach. What it does is it makes it possible. So, what we do, again, is we show, first of all, that h of k of x is equal to x. So we find h of k of x. Well, that would be h of the square root of x minus 10, which means we are putting the square root of x minus 10 in for x in that h of x expression. That would be the square root of x minus 10 squared plus 10. Well, when you square a square root, they are inverse operations, meaning they cancel each other out. And then the negative 10 and the positive 10 cancel each other out, meaning that we have shown that h of k of x is equal to x. That's perfect. That's exactly what we want. Okay, the second, we do k of h of x. Now again, that approach means we are plugging x squared plus 10 into k of x. So we're plugging x squared plus 10 underneath the expression for x. Well, the plus 10 and the minus 10 would cancel each other out, leaving the square root of x squared, which is equal to x. So again, we have shown that k of h of x is equal to x. So there we have shown that yes, h of x and k of x are inverses where x is greater than or equal to 10. Okay, now again, just real quick, if we look at h of x equals x squared plus 10, that function has a vertex at 0, 10. Okay, so when we restrict that domain, what it does is it creates that situation where only part of the parabola is there. And that piece of the parabola where x is greater than or equal to 10, and really I'm surprised it's 10, it really ought to be 0. That piece doesn't have the problem that the original graph has. Each input has a unique output. There are no repeated outputs, which means the inverse is also a function. And that's the part that makes my kids always get stuck on that. Well, why are we doing this domain restriction? And the reason we're doing the domain restriction is to make sure that both the function and the inverse are functions. Otherwise, we can't use function notation and we can't use composition of functions to check to see if they are inverses. Okay? All right, let's go on and do another one. So let's go to example